In this video, we're going to talk about thread synchronization. So let's take a look at a program. Let's take a look at this program first. I have a class called Account Without Sync. Okay, so we're going to be talking about synchronization. So this is a class written without synchronization, so we can see what the problem is before we discover how to fix it. So we're creating an executor for a thread pool here. And then we have a for loop that counts from 1 to 100. And we're creating 100 threads of this add penny task. So what is this add penny task? Let's go look at it. Add penny task adds a penny to an account. Account.deposit1 adds 1 cent. Okay, so what's an account? Let's look at the account. Now this is something you may not have seen before. This is an inner class. This is an inner class for account. So we have a class definition here, but this class is contained inside our other class. Okay? And if you notice, the class is private. So this is a small class called account that can only be used inside this other class. Since it's private and it's inside this class, only the account without sync class can access this inner class. But it's the code for a class just like we would see for any class. So our account has a balance field. We have a get balance method, and we have a deposit method. And we call deposit. It adds an amount, and we know because we've already seen the calling statement that it's a penny every time. Adds a penny onto our new balance. And then we have a thread.sleep here. Remember, that always has to be in a try catch block. So we're making this sleep for a millisecond. We're doing this to magnify the problem that can happen to make sure you can see it. And honestly, if you look at the book's example, I believe they used 5 milliseconds, and with 5 milliseconds, it wouldn't even work on my computer. I had to reduce it to 1 to actually see it happen. Okay, so our account has a balance and it's got a deposit method, and we're going to add pennies to that deposit method. Each one of these threads that we're doing here are going to add a penny to our account. So 100 threads adding 1 penny each to our account. So we tell it to start, we tell it to execute all 100 of these threads, adding a penny to our task. So add a penny task implements runnable, so it can be a thread. So all those threads are going to add a penny. And then after they're done, we're calling the executor to shut down. Now, when we call that executor and tell it to shut down, it's not going to shut down until they're done running. So we have a little while loop here that waits to see, checks the executor to see if it's terminated. If it's not terminated, this while loop's going to keep running. So basically this loop's going to sit here and do nothing except wait until all 100 threads are done running. And then we're going to print out the balance of the account. Okay, so 100 new accounts, each one adding a penny, each one in their own thread. Let's run it and see what happens. What is the balance? At the end is 3. 100 threads, each adding 1, and it only ended up with a balance of 3. It should be 100, right? It absolutely should. Let's run it again. 3. Oh, now the balance is 4 that time. There's 3. There was only a balance of 2. What's going on? It's not consistent. It's wrong, because we know we should get a balance of 100 if 100 threads each added a penny. What's going on here? What is the problem? So, a shared resource can be corrupted if it's accessed simultaneously by multiple threads. So our account is being accessed by 100 threads at the same time for all intents and purposes. Okay. So we know they don't quite execute at the same time, but they're all trying to execute at the same time. For example, if we just had two threads accessing the same bank account, here's what could happen. We could get the bank.get balance, and we can add 1 to it and make that our new balance. Okay, so we're setting the new balance right there of our account. Okay, and then thread 2 comes along and says bank.get balance. And right now the balance is still 0 because we haven't updated the balance in this line yet. So when thread 2 comes along, it gets the new balance and it thinks it's 0 and it adds 1 to it. Okay, so thread 1 has its balance and it just added 1 to this, and it sets that new balance using the new balance value it calculated right there, and that sets it to 1. But in the meantime, thread 2 didn't know that thread 1 had increased this to 1. It still thinks that it's 0, and it's adding its new balance to it, and it becomes 1. So as a result, both of these executed. Both of them should have added 1, and they kind of did internally, but this one overwrote the first one because it didn't know what had happened in the meantime between its two statements. Okay. So they're accessing a shared resource, which is that account balance. Actually, it's a set balance method. They're both accessing it at the same time, and they're getting inconsistent information between statements as they run. That's the problem that's happening, and it's happening so fast. This was an example with 2. It happened so fast in ours. Usually the number was 3 when it got done. That 100 times, only 3 statements ended up being effective in there. The rest of them got overridden because they're running all at the same time as fast as they can. All right, so how do we fix it? We need to write we just looked at that program before I came in. So this is talking about the add penny task, and that it's accessing the same methods multiple times, and there's no synchronization. So that's called a race condition. We don't want a race condition. When that happens, it's a race condition. Effectively, task 1 ended up doing nothing because task 2 overrode it in step 4 there. Common problem called race condition in multi-threaded programs. A class is said to be thread safe if an object of the class does not cause a race position in the presence of multiple threads. So how do you make it thread safe? How do we prevent the race conditions? And the example is the synchronized keyword. Okay. To avoid race conditions, more than one thread has to be prevented from simultaneously entering the critical region. What is the critical region? In this case, it's our deposit method. We can't have all 100 threads trying to access deposit at the same time. We need deposit to complete for the first thread before the second thread can access it. And once the second thread accesses it, then nobody else should be able to access it until after it's complete. And then the third thread can access it, and so on and so forth. So that deposit method is the critical region in this program. So what's the solution? We can use the synchronize keyword to synchronize the method, which says to the method, hey, only one thread can access you at a time. So we're going to go with the simplest way first in this video. I am going to show you how to do it very simply. We are going to go down to the deposit method. And right here, we are going to add synchronized, the synchronized keyword. What does that mean? That means when a thread tries to run this method, it does something called creating a lock. And it locks this method so that no other threads can access this method. It'll run the method, and once the method is done running, it releases the lock, and then the next thread can grab it, and so on and so forth. So just by adding this keyword, synchronized, let's see what happens. When we get done, our balance is 100. All 100 of our threads each added a penny like they were supposed to, because they waited in line for their turn to access that method, and that was enforced by the synchronized keyword. Now, that seems like a simple solution, and it is a simple solution. But there are things we can do to do it more manually that allows threads to cooperate a little bit more, and we'll talk about those in the next video.